Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video, we are covering new topics added for CCNA course 200-125, and this is section 3.4, implementing HSRP. Upon completion of this section, you should be able to configure, verify and troubleshoot HSRP, hot standby routing protocol. This is called a first hop redundancy protocol. So HSRP was designed by Cisco to allow for the gateway redundancy without any additional configuration on end devices. Routers configured with HSRP work together to present themselves as a single virtual default gateway router to end devices. So what happens here, for example, say these client machines, they got access to two routers. They can have both as a gateway. By default, you can assign only one IP address as a gateway. So if you don't do any HSRP or VRRP, for example, any other open standard first hop redundancy protocol, VRRP and GLBP, they have been removed from the Cisco CCNA course, so you only need to know HSRP. So without HSRP, you would have to define a gateway, default gateway, either this 172.16.10.2 or either this 172.16.10.3. So if the packets, for example, they're going to go this way, this is our design for as a default gateway. Now the problem is that if this fails, even though we have fully working another router that could be serving as a gateway, is not going to be utilized. The reason is because you have to go there and change the default gateway address, otherwise it's not going to work. Or you can do it in DHCP, but then you have to tell the client to do IP config release and IP config renew, which it would happen. It would be a big job. Anyway, with HSRP, what the routers will create is a virtual router, and then the end devices we assign that virtual router as our default gateway. So the end devices don't really know that there's two gateways. They just know, okay, there's one gateway. They don't even know there's a virtual. These two routers, they will keep this gateway running. One of the routers will be in active mode. One of them will be in standby. So active mode, when this PC, for example, sends anything to the gateway virtual router 172.16.10.1, the PC doesn't know that it's virtual. The active router will respond on behalf, say, okay, it's me. If active router for some reason fails, then the standby router will take over. So one of the routers is selected by HSRP to be the active router. Router acts as a default gateway for the end devices. Standby router, the second router, the other router is one of the standby, and if the active router fails, it automatically assumes the role of the active router. The active router provides a default gateway address to the end devices, consists of the virtual IP address and a virtual MAC address that is shared between both HSRP routers. End devices use its virtual IP address as a default gateway address. The HSRP virtual IP address is configured by the network administrator, while the virtual MAC address is created automatically. Only the active router will receive and forward traffic sent to the default gateway. If the active router fails, or if the communication to the active router fails, the standby router will assume the role of the active router. The default version of Cisco IOS 15 is version 1, so HSRP version 1. HSRP version 2 provides the following enhancements. Expands the number of supported groups to 4095 instead of just 255 in HSRP version 1. Version 2 uses the IPv4 multicast address 224.0.0.102 or the IPv6 multicast address FF02:66 to send hello packets instead of 224.0.0.2 used by HSRP 1. HSRP 2 version 2 uses the MAC address on the range of 4 zeros, quad zeros, 0C9F, F000 to quad zeros, 0C9F, quad F for IPv4, and 000573A, quad zeros through 00573A, 00FFF for IPv6. The last 3 hexadecimal digit in MAC address indicates the HSRP group number. HSRP version 2 adds support for MD5 authentication. The priority, the active and standby roles are assigned during the HSRP election process. By default, the router with the numerically highest IP address is elected the active router. However, the HSRP priority can be used to determine the active router. The router with the highest HSRP priority will become the active router. By default, the priority is 100. If the priorities are equal, the router with the numerical highest IP address is elected. Use the standby priority interface configuration commands to influence the election process. The range of HSRP priority is from 0 to 255. Then the HSRP preemption. By default, after router becomes the active router, it will remain the active router even if another router comes online with a higher priority or HSRP priority. To force a new HSRP election process, a preemption must be enabled using the standby preempt interface command. Preemptions triggers the re-election process. With the preemptions enabled, a router that comes online with the highest HSRP priority will assume the role of the active router. A router enabled for preemption with equal priority but a higher IP address will not preempt the active router. So highest IP address doesn't win. The HSRP states, when a router is enabled with HSRP, in transition between the following states: initial, these states enter throughout the configuration change or when the interface first becomes available. Learn, the router has not determined the virtual IP address and has not yet seen a hello message from the active router. In this state, the router waits to hear from the active router. Listen, the router knows the virtual IP address, but the router is neither an active router or a standby router. It listens for hello messages from other router or those routers. Speak, the router sends a periodic hello messages and actively participate in the election of the active or standby router. Standby router, the router is candidate to become the next active router if it sends periodic hello messages. Then active, the router currently forwards packets that are sent to the group virtual MAC address. The router sends periodic hellos messages. The active and standby HSRP routers exchange hello packets to the HSRP group multicast address every 3 seconds by default. The standby router will become active if it does not receive a hello message from active router after 10 seconds. These timers that can be exchanged. Okay, what I have here is a small lab. So for example, look at this config here. What we have is PCA has got access. He can go to the internet through router 3 and through router 4. That's one internet address, 200.1.1.1. Now, by default, you will configure PCA with a default gateway, like 10.1.34.3. That's why I have it right now. So if I go to PCA, which is my virtual machine here, so if I say IP config, I can see that that's my gateway, 10.1.34.3. So if I ping that internet address, I have a reply. Everything is fine. But okay, let me say put continuous ping here to that internet address. If I go to router 3 and I say config t interface 01, G00, and shut down. Now if I shut down that interface, even though there's a valid router on the other side in router 2, I can't use it unless I go to this PC and change the IP address or the gateway to router 4, like this. Yep, okay, and now I can ping it, right? That's not what you want, because imagine you have, for example, I don't know, 1,000 PCs or something. That's not going to work. So what we want to do is these two routers to have this virtual router and then to have this virtual router to be our default gateway. So here, for example, let me just copy this, and here I'm going to put the virtual router, right? An IP address of this virtual router is, let's put it here if we can fit it. So here, virtual router, and let's say the IP address is 10.1.34.251. That's our IP address of virtual router. Now in the PCs, instead of having one of these physical routers as a gateway, we put that virtual router as a gateway, 10.1.34.251. That's IP address of the gateway or PCA. Okay, now these three routers, the first thing they're gonna do is one of the routers, for example, is gonna be the active router, active. So let me write here, active, and the other router is gonna be in standby mode. So active router and standby mode. Right. Now, if you leave it to default, they look at the priority, yeah? So let me write the priority. The default priority is 100. So if we leave it to default, the priority 100 for both router 3 and 4, router 4 will become the active router. Why? Because it has a higher IP address. 10.134.4 is higher than 10.134.3. So that one will become active and this one will become standby. If we change the priority, for example, of router 3, say router 3, I want the priority to be 110 of router 3. Let me just copy this. Router 3. And this is router 1, the priority 100, which is default. Now, if I put the priority 110, then this router over here will become the standby, and this router will become the active router. Router 3 will become active, and router 4 will become a standby. Now, what happens if router 3 fails? For example, if the router 3 fails, for example, this interface breaks, then this router will take over, right? It will become the new standby. Oh, sorry, the new active router will take over. But what happens when this router comes back? The next router, router 3. The router 3 will end up being the standby router. For that, we're gonna need to write down. So here, for example, we need to write down the preempt. So preempt, when the router comes back, it will preempt. When the router comes back online, it will take over again as a active router. Okay, so let me just put this back here as it was, something similar to this. Okay, that's what we're gonna do. We're gonna configure, and then we're gonna change the IP address of this switch. We're gonna disable this interface. See it working. So I need to go to the interface. So interface G00, and do not shut down first. And then what I need to do is standby 1, for example, that's a group 1, and then the IP address of the virtual router. So IP, for example, we said 10.1.34.251. Then we say standby priority 110, and then standby 1 preempt. Right, do show standby. So we have group 1, 2 changes. Local virtual MAC address, you can see that's the MAC address of version 1. So quad 0s 07, 0C 07 AC, and then 01 is a group number. Now we are the active router, right? So if we say show standby brief, we can see the active local router is an active router, and standby router we don't have any yet because we haven't configured it. Okay, let's make some changes. Yeah, I want this to be the standby, router 4 to be the standby. So see the effect. Yeah, router 3 to be the standby, router 4 to be the active, and priority of router 4 we're going to change it to 120, and here we're going to say preempt as well. Okay, so if this is the configuration for router 3, so we go to router 4, Control-Shift-6X, and show if I see the sessions. Router 4 is 4, so 4. Config D, interface here is FA00. Then to standby 1 IP address 10.1.34.251. Then standby 1, say priority 120. Oops, 120. Then standby 1 preempt. end. Show standby brief. We haven't created that virtual router. So virtual IP address 10.134.251. The active MAC address, we can see it is in there. Preemption is enabled. Active router, so active here is local. Standby is 10.134.3 is this one here. Priority 110, right? They're gonna try and send it in 10 seconds. It's gonna expire. So every 3 seconds, the active router is gonna send in hello messages. So our priority is 120, which is being configured. So for example, now if we go to the client machine and we change here the IP address from 34 to 251, right? And say we ping that internet interface. So here, ping it there. Now, if I go to router 4 and that interface, the FA00 interface, are disabled. So config T interface FA00 shut down, right? How many pings I'm gonna miss until the next router becomes? Look, I just missed one ping. I disabled that interface, and I've gone to now. I'll go to router 3 to show standby brief. You can see the active router is local. If I go to router 4 and change it back, so no shut, and back to router 3, right? How many pings are missing? How many timeouts? Is there any timeout? Just got right away. We haven't seen any timeout at all. So if I go to router 3 and repeat the command, again, it's local. We have not changed. Unknown. So we're gonna see show standby. Just see show standby. So active router, it says is local. Standby router, now look, it's gone back from active to speak, and we lost again one more ping. And router 4 now is our active router. So active router is router 4, local is a standby. So as far as the client is concerned, it just lost a couple of pings and that's it. And the information is back online. So to configure, complete the following steps like we did. Configure HSRP version 2. So standby, you can change the version by just saying standby and then version 2, for example. But it has to be changed on both of the routers, yeah. Configure the virtual IP address, configure the priority, configure the active router to preempt the standby router in case where the active router comes online. Okay, there's HSRP enables the tracking and so on, but for the CCNA course, they just want to give you basic standby configuration. So if one of the interfaces fails, so for example, this was the active router, and we failed this interface, and you saw the packets that switched towards router 3. If I say, for example, if I go to my client machine, stop this, and do ARP -A, you can see that we have got the MAC address, the IP address, and the MAC address of our virtual router. The only reason why I seen this is because early on I was pinging router 3 and router 4. But here you can see the MAC address quad 0, 0C9F, F001 is the group number. And this is in hexadecimal digit. Last time I told my students, for example, said if I have a group, say group, if I do like this, standby 16, right? And IP, I don't know, let's say like this, yeah? Then what is going to be the group number? Yeah, so if I click like this, I go back here, right? What is this going to be? Pause the video and try and come up with it, right? The answers could be, all right, and see if you're correct. So could be 01. We could have 16. We could have 10, or we could have FF. Which one would you take? Right? You got choices. So you want to take here, okay, is this, because it's in hexadecimal. So 16 in hexadecimal is 10. How? Think about it. Hexadecimal digits: 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. A, B, C, D, E, F. So we have 0 to 9, A 10, 11, 12, 13, 14, 15. The next number after 15 is 10. So that's 16. So if I put standby 16, it represents hexadecimal numbers, and it's 10. Okay. Now we did this standby version 2, standby IP address, standby priority, and standby preempt, and then no shutdown. Show standby brief. Let's very briefly advertise who is a state, who's inactive, and who's in standby state. Most of issues will arise during one of the following HSRP functions: failing to successfully elect the active router that controls the virtual IP for the group, failure of the standby router to successfully keep track of the active router, failing to determine when control of the virtual IP for the group should be handed over to another router, failure to end devices to successfully configure the virtual IP address as a default gateway. So you can use the debug, HSRP debug commands. Again, you got to be careful with debug commands. So the HSRP debug commands allows you to view the operation of HSRP when a router fails or is administratively shut down. Common HSRP configuration issues. You can also use the debug commands to detect common configuration issues. The HSRP routers are not connected to the same network segment, either because of the physical layer issue or a VLAN subinterface configuration issue. The HSRP routers are not configured with IP address from the same subnet, therefore a standby router would not know when the active router fails. The HSRP router are not configured with the same virtual IP address. The HSRP router are not configured with the same HSRP group number, and devices are not configured with the correct default gateway. Thank you very much for watching. Please have a look at my other videos and don't forget to subscribe. This has been Astrid Krasniqi. Bye bye.